What would you see if you looked up at the sky right now? Naturally, your view would depend on the weather conditions and the time of day, but generally speaking, you'd find the sky as you usually do, with clouds, the sun or the moon, and stars twinkling in the heavens. This is all quite familiar and easy to understand since everyone on Earth is used to this daily spectacle. However, imagine if we could go beyond Earth's boundaries and find ourselves somewhere out in space. Suddenly, the view of the sky would change dramatically. Although the same sun would continue to shine, it might appear strangely different and perhaps unrecognizable. It's a challenging thought to grasp, isn't it? That's why I invite you to examine this reality with your own eyes, supported by scientific evidence and, of course, a healthy dose of imagination as we embark on our journey. To ground our exploration, it's worth remembering a basic principle. The intensity with which an object is illuminated increases the closer it is to its light source. You can test this at home using any light source and any object you have at hand. Notice that as you move the object away from the light, its brightness gradually diminishes. This same principle applies in the vast cosmic space. The farther we are from our star, the dimmer its light becomes. Starting with Mercury, the smallest and closest planet to the Sun, it oscillates in its distance from the Sun between 46 million and 70 million kilometers. This speedy world completes its orbit in just about 88 Earth days. If there were year-end celebrations on Mercury, they would be quite frequent. Its surface, marked by plains and craters, bears a resemblance to the lunar terrain. Without a strong atmosphere to moderate conditions, temperatures on Mercury can vary extremely, from frigid 173 degrees Celsius to scorching 427 degrees Celsius. Watching the Sun from Mercury offers a unique spectacle. Here, the Sun appears about 2.5 times larger than is seen from Earth. The lack of clouds and a dense atmosphere allows for a clear, unobstructed view, making the Sun not only dramatically illuminate the sky, but also dominate the landscape with its magnified size and intensity, contrasting sharply with the dark gray Mercury soil. Often called Earth's sister planet due to its similar size and composition, orbits the Sun at a distance that varies between approximately 107 million and 109 million kilometers. A Venusian year lasts about 225 Earth days, so if there were seasons as we know them, they would pass by quickly. Venus's atmosphere is dense and opaque, mainly composed of carbon dioxide, with thick clouds of sulfuric acid that completely cover the planet, hiding its volcanic and mountainous surface from curious eyes in space. From Venus, the Sun would be a less defined presence, visible only as an increase in light through the dense cloud layers. This constant cloud cover scatters sunlight, creating a uniform, diffuse glow that lights up the Venusian sky. Although Venus is closer to the Sun than Earth, the thick atmosphere filters and refracts the light in such a way that the Sun never appears as a clear, distinct disk, but rather as a bright glow permeating the toxic and overheated environment, where temperatures can reach around 465 degrees Celsius. The fourth planet from the Sun, known as the Red Planet, orbits our star at an average distance of about 228 million kilometers. With an orbital period of approximately 687 Earth days, a year on Mars is almost twice as long as a year on Earth, leading to longer seasons. The surface of Mars is dry, covered in a red desert with dunes, rocks, and mountains, including Olympus Mons, the largest known volcano in the solar system. Mars's atmosphere, primarily composed of carbon dioxide, is quite thin, which limits its heat retention capability and contributes to a wide range of temperatures, fluctuating between 125 and 20 degrees Celsius. Viewing the Sun from Mars, we would see a noticeably smaller solar disk than observed from Earth, due to the greater distance between Mars and the Sun. Despite this distance, the Sun still dominates the Martian sky, although it appears only about 2/3 the size it does when viewed from Earth. Without dense clouds to obstruct the view, the Sun shines brightly in a sky that can take on shades of blue at dawn and dusk due to the scattering of sunlight by the thin atmosphere. This scene provides enough light to brighten a Martian day, though with less intensity than experienced on Earth. The gas giant and the largest planet in our solar system orbits the Sun at an average distance of about 778 million kilometers. This celestial colossus takes about 11.86 Earth years to complete an orbit around the Sun, resulting in extremely long Jovian years. Composed predominantly of hydrogen and helium, Jupiter lacks a conventional solid surface, but displays a thick, turbulent atmosphere marked by colorful bands, storms, and the famous Great Red Spot. From Jupiter's perspective, the Sun would appear significantly smaller in the sky compared to how we see it from Earth, due to the vast distance between the planet and the star. It would be about 1/5 the size it appears on our planet. Despite this reduction in size, the Sun would still be a powerful source of light and heat, though much less intense. Sunlight on Jupiter is enough to illuminate the day, but the intensity is comparable to sunlight on Earth on a very cloudy day. Known for its stunning rings, is the sixth planet from the Sun and orbits at a distance of approximately 1.4 billion kilometers from our star. This gas giant takes about 29.5 Earth years to complete a full orbit, meaning a year on Saturn is nearly 30 times longer than a year on Earth. Saturn is primarily composed of hydrogen and helium, and like Jupiter, it has no solid surface, but an extensive atmosphere with layers of clouds and extremely fast winds. From Saturn's viewpoint, the Sun appears much smaller in the sky, only about 1/10 the size it is perceived from Earth, due to the great distance between the planet and the Sun. The Sun still provides daylight during the Saturnian day, but with much reduced intensity, akin to a cloudy day or twilight on Earth. The sunlight that reaches Saturn, though enough to outline the rings and cloud layers, is considerably weaker, significantly altering the perception of day and night compared to the earthly experience. The seventh planet from the Sun orbits at a colossal distance of about 2.9 billion kilometers from our star. This ice giant takes about 84 Earth years to complete a trip around the Sun, meaning that the seasons on Uranus last more than 2 decades each. Uranus's atmosphere is mainly composed of hydrogen and helium, with a significant presence of methane, which gives it its characteristic blue-green color. Due to its extreme tilt of nearly 98 degrees, Uranus has peculiar rotations, with its poles alternately pointing almost directly toward the Sun and then away, resulting in extreme variations in sunlight throughout the year. Seen from Uranus, the Sun would appear as a small bright point in the vast sky, much smaller than seen from Earth due to the immense distance between the planet and the Sun. Despite its distant presence, the Sun is still capable of faintly illuminating Uranus's day, but with light that resembles dusk on Earth, never reaching the intensity of midday as we experience on our planet. The faint sunlight contributes to the mysterious and cold appearance of Uranus, with its hazy atmosphere and pastel tones dominating the visual landscape. The distant adventurer of the solar system orbits the Sun at a cold distance of about 4.5 billion kilometers. This ice giant takes its time, about 165 Earth years, to complete a full orbit around the Sun. So, if you plan to celebrate your birthday on Neptune, better be patient, because parties are extremely rare. With an atmosphere rich in hydrogen, helium, and methane, which gives it that iconic bluish hue, Neptune is shrouded in fast-moving clouds and fierce storms, with winds that can exceed 2100 km/h. From Neptune, the Sun is less than a bright star in the sky, more like a distant lamp someone forgot to replace with a higher wattage bulb. Small, but technically still visible, the Sun shines as a point of light brighter than the surrounding stars, but it doesn't provide much in terms of warmth or daylight. The light that reaches Neptune is so weak that you could stare directly at the Sun without blinking, though we don't recommend trying that at home or on any planet. This subtle illumination is just enough to highlight Neptune's stormy features, leaving the rest of the planet in an ethereal, cold twilight. The small outcast of the main planet club orbits the Sun at a colossal distance of about 5.9 billion kilometers. This dwarf planet takes 248 Earth years to complete a trip around the Sun, marking an extensive and slow journey through space. Pluto is known for its icy and mountainous surface, covered in frozen nitrogen, methane, and carbon monoxide, presenting a surprising geological diversity for such a small body. From Pluto's perspective, the Sun is just another bright star in the night sky, not much larger than the other stars we can observe from Earth. If you're expecting to see a dramatic solar spectacle from Pluto, prepare to be disappointed. The sun there looks more like a persistent bright spot that barely competes with the glow of a dim bedside lamp. Despite its low intensity, the sun can still cast a soft light on Pluto's surface, just enough to make a day on Pluto not just a slightly less dark night. In this video, we explored how the appearance of the sun changes drastically when viewed from different planets in our solar system. We started with the basics of how proximity to a light source affects an object's brightness, applying this logic to space to understand how sunlight's intensity varies as we move farther away from it. We observed the sun from planets like Mercury, where it appears gigantic and bright due to its proximity, to Venus with its dense atmosphere, and Mars with its distinct red hue. A fascinating curiosity that complements the theme of how the sun is seen from other planets involves the influence of solar gravity on the time it takes for sunlight to reach those planets. Although many of us know the speed of light as approximately 299,792 kilometers per second in a vacuum, the sun's gravitational influence can actually affect this speed as light travels through the warped space around the sun. This phenomenon, known as gravitational time dilation of light, was predicted by Einstein's general theory of relativity and has intriguing implications for astronomical observation. For example, it takes about 8 minutes and 20 seconds for sunlight to reach Earth, but as we move farther from the sun, like on Mars or Jupiter, this duration not only increases due to the greater distance, but can also be subtly affected by how the sun's gravity curves the space-time around it. If you found it intriguing to see how the sun can look different depending on where we are in space, give this video a like and subscribe to the channel. And if you enjoy exploring scenarios where we imagine interesting theories, don't forget to check out our video on "What if a human fell into a black hole?" Hit the notification bell for more explorations of the universe's wonders. See you next time.